Our third example does use explicit equations. It starts with our square root graph. And we've got the -2 and a big important note. Oh my goodness, this one's asking domain and, did the last one say domain and range? I feel like I didn't read it at the end. Oh, it did. Oh, I forgot to reread the question again. Okay, we'll finish this one up first. We have to do, and does it say each one? Oh, it does say each one. So the red original graph, domain and range, the easiest thing to do is just say what it can't equal. So x can't equal 0, y can't equal 0. That is perfectly fine for domain and range. And then for our purple one, now the x value can't equal -1 and the y value can't equal -4. We did so much work in that question. It was unfair for them to ask domain and range after doing that much work. Don't you agree? Like, you deserve to move on to the next question. It's not, it's your teacher's fault for not reading the question. Okay, same thing here. This is an explicit equation. Okay? So, we're going to move the 2 over. Then you're going to go from left to right. That negative is outside the function. Vertical, right? So that negative is going to be a vertical reflection. Inside the function, you've got the 3x and the 3. So first of all, what's the first 3 going to do? Horizontal or vertical? Stretch or compression? Compress. Horizontal compressing by 1/3. Okay? Then the second 3. Horizontal or vertical? Horizontal. Horizontal translation, right? Left or right? By how many? No. Not by 3. How many are we going to go left?
1.
Only 1. Why? Because it's not in factored form. Can you see yourself getting tricked by that? Absolutely. That's why I did it that way, because you're like, it's good to trick yourself first and then realize, oh, I got tricked. And you don't like to be tricked, right? Friend plays a joke on you, they do it over and over again, and you're like, okay, I'm not gonna fall for that anymore. So, I'm going to take my time first and rewrite this. And when I rewrite it, right, I made the note that wasn't factored, so I take the 3 out, leaving with x plus 1, and then I add my 2. Now I can go through and list vertical reflection. You're going to have to multiply your y values by -1. Horizontal compression. You're going to multiply your x values by 1/3. Horizontal translation 1 to the left, and a vertical translation 2 up. On your original graph, definitely going to use 0, 0. What are your other points on your square root graph? That when we graphed them, when we did our table of values, what are other points you can label easily and quickly? Well, there was, according to this, it would be there, 1, 1. There would be 4, 2. Those are usually the 3 that we do. I'm going to tell you that those 3 are perfectly fine to use, but there's an even better one in this example that I would use. I would go so far and use 9, 3. Square root of 9 is 3. Again, you can find points quickly just by doing mental math and doing the table of values. Square root of 9 is 3. Square root of 4 is 2. So you definitely have to do 0, 0, because that's your starting point. And then as a second point here, I would probably do 9, 3. Because I already know my x values have a fraction, so I pick something that works out nicely. If you used 1, 1, it is not wrong.
Sorry for the interruption. Would grade 12 students with the last name starting with A through F please
go to the gym for your picture. That's grade 12 students with the last name starting with A through F. Please go to the gym for your picture.
So if you're in grade 12 and those are your names, you haven't had your picture, make sure you go down. So especially when you get busy like this one, it really is nice if you do all your stretches, compressions first. So this will still be at 0, 0, but this one is going to be at 3, and this one at -3. Then 1 to the left will be -1 and 2, and 2 up will be 2 and -1. Go to my graph. And usually, I like to make a new graph off to the side. Sometimes they'll say, can you put it on the same graph? Sometimes putting it on the same graph just makes things look really busy. So I like to do it as a separate graph. I'm going to make a tiny little E error on this graph, and you see if you can see what I did wrong. So -1, 2, and 2, -1. -1, 2 was my starting point, right? This is the key point. This is the key point. Where did the key point go? Right there, -1, 2. That's there. Just so I know where it's starting. I had a vertical reflection, so if I think about flipping it, the shape of my graph has to look like this. This would be a 4-mark question, and I would get 3.5 out of 4, because I made an E9 error. Anything you see that's wrong with my graph? E9 has to do with graphing. Sometimes it's arrowheads. Sometimes it's labeling your scale. Like this looks like nothing's wrong, right? But if you just do a ticking mark, I know we feel like every time, if unless otherwise stated, you go by 1s, I know, but they're like, well, you might be going by 7s. We don't know. So you have to also, on a graph like this, label something. You can either label like this. As soon as I label that point, everything would be fine. I don't even have to, I'd recommend also labeling that second point. That's fine. Or as soon as you go 1, 2, 3, 1, 2, 3, it's also clear where your points are. But with nothing labeled, they'll say, you didn't label, take off a half a point. Okay, questions? Oh, domain and range. I read the question. I did better this time. Teacher is improving. This is always a good sign. The original one, domain and range. Domain, the smallest x value is 0 and goes up forever, so that's 0 to infinity. Same thing with the range, the smallest y value is 0, goes up forever. And then on our purple graph, now my smallest x value is -1. And I don't have a smallest y value, I have a biggest y value, so it starts at -infinity and goes up to 2. And you can circle questions 8 and 10.